Every day for 14 days, I'm going to be posting one question from the Edexcel. And not only that, I'm going to be creating a bonus question for each of those questions to really supercharge your revision. Today, we're going over an easy vectors question, but my part C turns this grade E, grade D question into something that's more like a grade A, B question. So stick around for that. Let's go. This is a straightforward question. It starts out with two 3D vectors. Now, just because they're 3D doesn't make it more difficult. We'll start with the position vector A. So a position vector means just from the origin, so OA. And I always like to write them as column vectors. Who likes I, J, and K? I don't know. And then we'll do OB is 2, 4, and A. It's just so much easier to work with them as column vectors. Now, part A says, show that. Now, these lines mean magnitude. Magnitude of OA is root 38. So, hopefully, by now, you know that when we want to do the magnitude, we just do Pythagoras. We take each of those and we square them, and we get 5 squared plus 3 squared plus 2 squared. So it's 25 plus 9, that's 34, plus squared 4, that's root 38. Okay, and that's all you have to do. That's a really easy 1-mark question. Part B then says, find the smallest value for A for which OB is greater than OA. The magnitude of OB is greater than the magnitude of OA. So this is an inequalities question. Clearly, we've got part of this already. We've done the magnitude of OA, but we now need to just do the magnitude of OB. So if we do that, it's the same process, but obviously now we're going to have one unknown. So we've got 2 squared plus 4 squared plus A squared, and that comes out as 4 plus 16, so that's 20 plus A squared inside of the root. And then we just set up our inequality. So we're going to put the root of 20 plus A squared is greater than the root of 38. Now, because we know both sides of this inequality are positive, we can square both sides. Just be really careful. You can't always square both sides. So we can actually say 20 plus A squared is greater than 38. This is essentially a quadratic inequality. Now, this question didn't say anything about not using calculator technology. So you can actually do this one on your calculator. So you can have A squared, and then we've got 20, take away 38, that's minus 18 is greater than 0. So you can actually just take your calculator, go to the inequality section on your menu, go to polynomial, the one that looks like a quadratic, and your A is 1. Your B is 0 because there's no B term, and then your C is minus 18. And so you can just type that in and solve it. And what you get is A is greater than 3 root 2, which is, if we're looking at it as a decimal, is 4.2 roughly. So you've got that. Now, a lot of people leave it there and lose 1 mark, and have a look at why they might do that. It wants one value of A. It wants the smallest value of A, and it says here that A has to be a positive integer, so it needs to be a whole number. So your final answer is A must be 5, because if it's got to be greater than 4.2, it's got to be 5 as the smallest value. Okay. Easy A and B there. That's a super simple question. Now I'm going to reveal the bonus part question, which is a little bit trickier. Okay, let's have a look. So we've got a new vector, and it's defined as P, 2P, and 3. So I'm going to write this down. So we've got OC is P, 2P, and 3. Okay, well, P is a constant, not a positive constant. Given that the angle between OC and the positive y-axis is 60 degrees, find the exact possible values of P. I think that you should try to sketch this out, even if it's a rough sketch. So if we tend to write it like this. So we've got X, then we have Y like that. Then we've got Z coming up. So if we've got P, 2P, and 3, so that means we're going P along, 2P up. I'm just assuming P is positive here, and then 3 up in the Z. So I'm just going to do it as if it's there. So I'm going to draw a line. So that's my C, that's my O at the origin. So this is my OC. And we are trying to find the angle made with the Y. So we want it coming down to the Y. So we want a right angle here going from C to the Y-axis. And this is the angle here that we want. This is our theta. We know that this part here is going to be 2P because we went up 2P in the Y direction. So this part here is 2P, and this part here is the other part of this triangle that we know, and that is the magnitude of OC, okay? So we do know 2 parts of that triangle. We don't know all of it, but that's enough for what we're doing. So this is a right angle triangle, so you're just using SOHCAHTOA. So we're going to be doing here cos theta equals A over H. So we've got cos 60 equals our adjacent is 2P. Our H is the magnitude of OC. So clearly we need to find the magnitude of OC here. So let's do this over here. And we're doing the same thing. So we've got P squared plus 2P squared, don't forget to put that in brackets, plus 3 squared. Now that comes out as we've got 5P squared, because that's 4P squared, plus 3 squared is 9. Okay, so we've got that. So we can replace our OC here. So this side becomes 2P over the square root of 5P squared plus 9. Cos of 60 we know is a 1/2, so you could have typed that in, or you might know off by heart. And then we've just got to solve for p. So I'm going to bring this up here. So we get root of 5p squared plus 9 is equal to 4p. Square both sides, so we've got 5p squared plus 9 equals 16p squared. Then that gives us 11p squared equals 9, p squared equals 9/11. And if we square root both sides, we get 3 over root 11. Now there's something wrong with that answer. Have a look. I've deliberately left something out. What have we done wrong? Okay, hopefully you're thinking there can be two solutions here. This is a plus or a minus. So it didn't say p had to be positive. It said the angle made with the positive y-axis. It just said that p had to be a constant. So we have to say that. You could rationalize it just to make it a bit nicer. So that's plus or minus 3 root 11 over 11. Okay, so we have found the two exact. Now we've left it in third form because it asked for exact, and that would get you all the marks. I think in an exam that would be something like 3 marks, but a harder 3 marks. Definitely. Tomorrow's video is going to be question 4 on the paper, and it's a little bit of a deep dive into some more complex calculus. If it's ready, I'll pop it around the video somewhere here. Otherwise, hit the subscribe button so you don't miss the daily video. I'll see you then.